Subscribe to Careerflite and press the bell icon to never miss our videos.
Good morning, students. Welcome you again to this Careerflite initiative of geography classes. And I would request you to please subscribe the channel and share the video with your friends. So let's start the class. And the topic that we are going to discuss today is atmospheric circulation and weather system. Now, when you talk about the atmospheric circulation, it means the movement of wind. We're going to talk about the movement of wind. And as we know, what is wind? Wind is the movement of air from high pressure to low pressure. Simply, wind means movement of air. Air will move from one place to another place. Now when the air will move, when there is a high pressure in one zone and there is a low pressure in another zone, so the wind will move from this high pressure zone to the low pressure zone. This is the general direction of the movement of wind. So there have to be two zones, one is high pressure zone and one is low pressure zone, and this zone will decide the movement of wind. And this the in all over the earth surface, over the earth surface we can find a particular direction of winds. Some of the winds, if you have heard name of the winds like northeast trade winds, southeast trade winds, westerlies, they're actually a fixed pattern of wind. They are moving in a particular direction, and in every part of the year we can find it, though their frequency may change, though their not frequency, their speed may change. Sometimes they may be very fast, sometimes they may be very slow, but they will move in a fixed direction. Now why they're moving in a fixed direction? Because of presence of different pressure belt, low pressure belt, high pressure belt, like that. So let me see how the wind moves over this earth surface. So air circulation means the circulation of air around the surface of the earth. Okay, now because of this circulation of air, masses of air moves, their mass of air, we call it air mass also. When a mass of air with a particular mass of air with a distinctive characteristics like a temperature, high temperature, low temperature, dryness, is it dry or it may be humid also. Based on that we can classify the air into different air masses. So when a particular air mass moves from one place to another place in a particular different type of air mass, suppose this one is cold air mass and this one is warm air mass. The temperature here is warm of this air mass, the temperature of the air here is cold. And if they move to opposite direction, suppose cold air mass is moving towards the warm place and warm air mass is moving towards the cold place, in this movement there will be interaction of both these winds, there will be interaction of both these air masses, and that will lead to disturbance in the weather. It will lead to disturbance in the weather, and it will change the weather of the particular place. So we can find different types of disturbance in the weather like tropical cyclone, tornadoes. All are caused by because of movement of these air masses having different characteristics. Now in this chapter, first we'll try to see what is pressure, atmospheric pressure. Atmospheric pressure. Now it is actually the pressure exerted by the column of air. It is a pressure exerted by a column of air in a unit area. Suppose if you take a unit area of 1 meter square, suppose it is 1 meter everywhere in all the site. This is a unit place, it is a unit area. What is unit area? Okay, if you try to find the pressure exerted in a unit area by a column of air, suppose this is the height of the atmosphere from the surface to the atmosphere. Surface means at the sea level. We are taking the surface at the sea level. Sea level. Okay, the surface, the unit area at the sea level, and from that unit area, if you try to find the pressure that will be exerted by the air molecules in this column over this unit area, there will be and various air molecules will be there, and the pressure that will be exerted by these air molecules on this unit area is known as atmospheric pressure. It is a definition of atmospheric pressure. In actually it is the pressure that is exerted by column, all the air molecules. It is the pressure that is exerted by all the air molecules over the surface of the earth. And just for definition, we'll consider that this is the column of air particles, air molecules, that is exerting a pressure on a particular unit area. That is the definition of atmospheric pressure. Now how we measure the atmospheric pressure? There is a instrument called barometer. We use this instrument called barometer. Barometer is used to measure pressure. Okay, and the unit is millibar. Millibar is the unit of atmospheric pressure, and this is the instrument. Okay, the instrument that we use for measuring the atmospheric pressure is barometer. Like we use thermometer to measure the temperature, in the same manner we use barometer to measure the atmospheric pressure, the difference in the atmospheric pressure in different places. Then again, the unit will be like degree Celsius in thermometer. In the same manner, it will be millibar in barometer. We'll take the measurement in millibar. Now we'll try to see the different types of atmospheric pressure that we can see in different part of the earth. Just consider this is the earth, this is the globe, this is the globe, and in this globe, this is the equator, this is the subtropical area, this is the subpolar area, and this is the pole. In the same manner, again in the southern hemisphere also we can draw it subtropical, then subpolar, then polar. These are in the southern hemisphere and they are in the northern hemisphere. 90-degree north, then 60-degree north, 30-degree north, 0 degree, then again 0 degree is the equator, 30-degree south, 60-degree south, then again 90-degree here south. Here we try to see how the different pressure belt originate over the surface of the earth at the different latitudes. At the different latitudes we can find different pressure belt. Now why this pressure belt originates? First of all, just see, try to understand why low pressure zone is created, how the low pressure zone is created, and how a high pressure zone is created. When the sunlight is very high over a particular latitude, when the intensity of the sunlight will be high at a particular latitude, then at that area, suppose at this zone, the intensity of sunlight is more. Now what will do, the sunlight will expand the air molecules here. The air molecules that is present over the surface of the earth will be expanded by this heat of the sunlight, and because of this expansion of these molecules, they will become, the density will decrease. The density of the air molecule will decrease because they are expanding. If the molecules are close to each other, the density is high, and if the molecules are moving away from each other because of providing heat, the energy heat, they will expand, and because of this expansion of the air molecules, the density will decrease, and because of that they will become light. These air molecules will become light, and because of that they will rise. These air molecules will rise because they have become light in weight. The weight of the air molecule will be light now, and because of that these air molecules will move towards the upper part vertically, and because of that this place, in this lower part nearby the surface of the earth, here the pressure will decrease because air molecules has decreased now. Because of less amount of air molecules that is present at this lower part nearby the surface of the earth, the air molecules will, because of reduction of the air molecules, the pressure will decrease. So that is how low pressure zone is created. Here low pressure zone will be created. And in the same manner, if the sunlight is less in a particular area, suppose the sunlight here is less or coming in a slant direction with an angle in the polar area, suppose this is a polar area, and here sunlight is coming from another direction with a slant rays, and because of that the amount of heat that will be received by this particular surface will be less. The amount of heat that will be received by this particular area will be less, and for that the air molecules, the density of the air molecules will be high compared to the lower, this at this zone the air molecules density is low, where the sun rays will fall directly. The place where the sun rays will fall directly, the density will be low. The density of the air molecules will be low where the sunlight will fall directly, and the area where the sunlight will fall with a slant rays, and the intensity of the heat will be less. So because the intensity of heat is here high, that's why there will be low pressure will be created here, and because it will be cold area because sunlight is less here, that's why the density of the air molecule will be high, and because of that it will have a high pressure. The cold areas will have high pressure. Okay, I'm getting comment here. Good afternoon. And if you have any doubt, you can ask me, you can put in the comment, we'll try to answer it. Okay, the zones, the area where the temperature, the heat is less, it will have high pressure. And the area, the latitudes, the zones where the temperature will be high, they will have low pressure. Now I have already explained the chemistry behind it. What is the chemistry behind it? Why it is low pressure and why it is high pressure? I am again describing it. Where the sunlight will be high, the intensity of the light will be high, mean it will have more temperature. And because of high temperature, the molecules, air molecules here will expand. When they will expand, density will decrease. So they will become light in weight. So that is because of that they will rise. This air will rise vertically, and because of that there will be less amount of air molecules nearby the surface. That's why this surface will have a low pressure. The pressure that was exerted by the air molecules will be low here. In the same manner, in the polar area, we can find that since the heat is low here, the air molecular density will be high here, and because of that, the density will be high, and because of that, the weight of the air molecules will be more. That's why it will have a high pressure. Now, this concept, this idea will help us to know more about the air circulation. That is the specific part of the different airs over the surface of the Earth. Now, we are going to describe these different types of airs on the surface of the Earth through this diagram of the Earth. Okay, this is the Earth. Okay, I think it is not coming in the frame. This is the Earth surface. Again, we are going to divide this Earth surface into equator, 0 degree. Equator means 0 degree, low latitude. When I say low latitude, it will be equator only. Less is the degree, less is the equator latitude. Low latitude means 0 degree. This is the 30 degree. This is the 60 degree. Means they are mid latitude. This zone is mid latitude. As we keep on increasing the degree, the latitude will keep on increasing. Low latitude, mid latitude. Then again, this is the high latitude. 90 degree at the pole. As we know, at the pole, the degree is 90 degree. Then again, if you move towards the southern side, southern hemisphere, it will be 30 degree. Again, it will be 60 degree. Again, it will be 90 degree. We'll write it S for south, southern hemisphere. This is for north. So at a different latitude, we can find the sunlight is different. The intensity of the sunlight will be different. Okay, it will be different at different latitudes. Why? In this zone, in this tropical area, tropical area means the zone between Tropic of Cancer and Tropic of Capricorn. In this zone, we can find enough sunlight. The amount of sunlight, the intensity of sunlight will be very high in this tropical area. So the sunlight, because the sunlight is more here, so this zone should have low pressure, especially this equatorial low, nearby this equatorial region. Nearby this equatorial region, the belt, the pressure belt should be of low pressure belt. And as we move towards this zone at 30 degree, here the pressure will be high. So the low pressure zone here is called equatorial low. At 0 degree, the low pressure belt is known as equatorial low. Equatorial low is a pressure belt. Remember, equatorial low is a pressure belt. That low pressure belt is forming over this nearby this equator. That's why we call this equatorial belt as equatorial low. At the 30 degree north, we can find a pressure belt that will be high, that will have high pressure, and that zone is known as subtropical high. Subtropical high means at this zone at around 30 degree, the belt at this belt near this latitude, the pressure will be high here, and this zone, this belt is known as subtropical high. Then again, at 60 degree north, this zone is known as subpolar low. Why low? Because at this belt at 60 degree north, the pressure, the air pressure will be low. That's why it is known as subpolar low. And then at the pole area, at the pole, the pressure will be high because it is very cold temperature. Temperature is very cold. The amount of sunlight is very less there. Since the amount of sunlight is very less here in this polar area, the air molecules cannot expand. They will be dense. They will be very dense. They will, because of their high density, they will they will have a very high weight, and because of the high weight of this air molecules here nearby this polar area, they will exert a high pressure, and because of this high pressure, this zone is known as high pressure zone, polar high. This zone is known as polar high. Okay, in the same manner, in the southern hemisphere also, you can write the pressure belt like subtropical high, subpolar low, again polar high. Okay, these are the different belt. These are a different belt of the on the surface of the earth. Okay, these are a different pressure belt. These are different pressure belt on the surface of the earth. At the equator, the pressure belt will have a low pressure. That is why it is known as equatorial low. Why it will have a low pressure? Because of the presence of enough temperature. From where the temperature will come? The heat energy from the sun at this zone. That's why the pressure here is low. It is known as equatorial low. Again here at 30 degree it will be high pressure zone, subtropical high. Then again at this 60-degree north the pressure will be low. That's why it's known as subpolar low. Again at this polar area the pressure will be high. That's why it is known as polar high. In the same manner again in the southern hemisphere you can find the same pressure belt at different latitudes. Then we'll see, as we have seen, wind moves. Wind, wind is the movement of air from high pressure to low pressure. So in this nearby the surface of the earth, we can again see that how wind moves here. As we have seen, as we have already talked that air moves from high pressure to low pressure. So we'll see where is low pressure. It is the low pressure. Equatorial low is the low pressure. So air should move from this subtropical high to this equatorial low. Air should move from this high because this is a high pressure zone. This is also high pressure zone nearby the surface. I'm talking about the surface here only now, not about the upper air circulation. We'll talk about the upper air circulation later. But at the surface, nearby the surface, because nearby the surface, the pressure zone will be low nearby at equator. That's why air should move from this high pressure, subtropical high, both from the southern hemisphere and from the northern hemisphere, from the 30-degree north and 30-degree south. This high pressure belt, air will move towards the equatorial low. Okay, air should move towards the equatorial low. Then again, here you can find subpolar low. That's why from this subtropical high pressure zone, air should move to the subpolar low pressure zone. In the same manner, in the southern hemisphere, you can find from subtropical high, air should move towards the subpolar low. And in the same, again in the same manner, if you see the polar area, we know that they are having high pressure. Because of that, air should move from this high pressure towards this subpolar low pressure belt. Again, from here to subpolar low. So this should be the direction of the wind generating about the surface of the earth. But if you see the movement of wind on the surface of the earth, it is not exactly perpendicular to the latitudes. They are not moving exactly perpendicular to the latitudes, but they are deflecting. They're moving with a particular direction. You can find the air do not move from this subtropical high towards the equatorial low directly perpendicularly, but they deflect with an angle here. Then again this wind will also deflect in this manner. Now how this why this deflection takes place? Again this will deflect, this will also deflect in the same manner. It will also deflect. Okay, the air deflects, they do not move perpendicular to the belt, to the different latitudes. Why this takes place? Because of the force. There is a force on the surface of the earth. There is a force on the surface of the earth. It is being generated every time, and this force, because of the rotation of the earth, is known as Coriolis force. There is a force called Coriolis force. Coriolis force. Now what is Coriolis force? Coriolis force is a force that is generated. Where it is generated over the surface of the earth. जो surface है earth का उसके ऊपर एक force generate हो रहा है. Okay, and why this force is being generated? It is generated because of the rotation of the earth. Earth is rotating very fastly, right? And because of this rotation of the earth, a new force, a kind of force is there on the surface of the earth, and that force is Coriolis force. And what is the effect of Coriolis force? What is the effect? How we can feel the force of Coriolis? So any free moving object, if you try to move, if you throw any free moving object, okay, it may be water, it may be running water. Not running water, actually it is a flow of water over the sea, huge pile of water. Then again, movement of wind, movement of wind. then flow of ocean currents. They are actually flow movement of particles, molecules. Then any particles and molecules, whenever they will move in a particular direction, they have to deflect to another direction. Whenever a free moving object, a free moving particles will move in a part, if you try to move a particle in a particular direction, they are not going to move in the same direction, they will deflect. Okay, and this deflection will take place because of this Coriolis force. Now how it will affect in different hemisphere? If any free moving object is there in the northern hemisphere, it will deflect towards the right. In the northern hemisphere, in the northern hemisphere, suppose you are throwing something from here, from this point. Okay, from this point, at the local level you cannot find this effect. If you throw something, it will go directly. But if you see this one in a rotating circle, like in a park, you can see this in a rotating circle like this. If you keep on rotating, if two people are sitting in a different corner, okay, I'm showing the example here. Suppose if you go to the park, you can find this kind of some circular things where you can sit down and you can keep on rotating there. And if you throw something, if you're sitting here and your friend is sitting here, if you throw something directly to this person, it is not going to move. If you try to throw a ball to this person from here to there, this ball will deflect. This ball will not move directly to this person, but it will deflect. It will move towards another direction. Now why this is taking place? Because a force is generating here also because of this rotation of this ring, and this force is Coriolis force. In the same manner, the earth is rotating. Earth is a bigger ring. Okay, in this earth is rotating. Because of that, any big movement and any movement at a very high level, any movement at a very high level will face this force, Coriolis force. So because of the rotation of the earth at very fast speed, the movement of wind and the movement of ocean current, mostly they get deflected. And now what is the effect? In the northern hemisphere, in the northern hemisphere, any free moving object will deflect towards the north. Any free moving object will deflect towards the north. First, I'm talking about the northern hemisphere, the upper part of the earth, northern hemisphere. Then we'll talk about the southern hemisphere. In the northern hemisphere, suppose air should move. This is a high pressure and this is a low pressure. Air should move from here to there directly. But instead of that, air will deflect towards this side. Instead of moving directly from here to there, air will deflect towards this right direction, where in the northern hemisphere. And if the same thing happens in the southern hemisphere, and if the same thing happens in the southern hemisphere, what will happen? Suppose this is a not high pressure, this is a low pressure. And in case of southern hemisphere, what will happen? Anything that will move, any air that will move from high pressure to low pressure, it will again deflect towards the left side. It will deflect towards the left side. Now, what is the difference between this northern hemisphere and southern hemisphere? What is the effect of this Coriolis force in northern hemisphere and southern hemisphere? Any free moving object, for example, wind or water, in the northern hemisphere, because of Coriolis force, water or wind, they will deflect towards the right, and in the southern hemisphere, they will deflect towards the left. Now, we are going to see this effect of Coriolis force in this movement of the air. So we are going to see the effect of this Coriolis force in the movement of the air. Now what we have seen here, air should move from this high pressure to low pressure in this direction. But because of the Coriolis force, what will happen? Since this is in northern hemisphere, this is the equator, and over the equator is northern hemisphere. So this wind should deflect towards the right. For the right means this wind should come in this direction. So this will be the direction of the wind here in the northern hemisphere. Then again in the southern hemisphere, it will deflect towards the left in this direction. It will deflect towards the left in this direction. Then again, because you have seen that the air should move from high pressure to low pressure in this side, the wind should move from this high pressure to low pressure directly. But because of Coriolis force again, it will deflect towards the right. Means the wind should move from here to in this direction. In the same manner, what will be the effect in the in the southern hemisphere? From this 30 degrees south subtropical high, it will move. Generally, it should move from this subtropical high to subpolar low directly perpendicularly, but because of Coriolis force, it will tilt towards the left. Its left will be this side. its left will be this side. Then again, in the subpolar high, in the polar region, in the polar high, again from the polar high region, air should move toward the subpolar low directly. But because of Coriolis force, it will deflect towards the left in this direction. Here again, it will deflect towards the right. Okay. So these are the general pattern of movement of air at the surface. This is the general pattern of movement of air at the surface of the earth. Now, according to direction from where the wind is coming, according to direction from where the wind is coming, we have given name to the winds. We name the winds from where the wind is coming. You have to remember this point. Every time we name a wind, we name a wind according to the direction from where the wind is coming. Suppose the wind is coming from eastern direction, western direction. Suppose this is also the directions here. North, south, east, west. Okay, north, south, east, west. I hope you can see the directions here. North, south, east, and west. So if the wind is coming from this direction, this is northeast, right? North and east. So it will be northeast. If the wind is coming from this direction, then the name of the wind will be northeast wind. And if the wind is coming from this direction, in between east, south, and east, it will be southeast wind. In the same manner, if the wind is coming from north and west, it will be known as northwest wind, then again southwest wind. And according to, we have given the name of the winds according to origin of the wind, from which direction it is coming. Accordingly, we are going to name the winds on the surface of the earth. So here you can see this wind is coming from north and east direction. Okay, this one, north, south, east, west. You can find here that this wind is coming from here, northeast direction. That's why this wind from 30-degree north subtropical high towards the equatorial low is known as northeast trade winds. We apply this word northeast trade winds. Now, why we are using trade winds? Because the in ancient times the Arabs and Chinese, all this business in this economic environment at that time, they use these winds to move their ships from one place to another place. In ancient times, they use this stress. They use these routes with the help of the force of the wind. They used to push their ships. That's why we call it trade winds. This one is northeast trade winds. Why? Because it is coming from north and eastern direction. And this one is southeast trade winds. Southeast trade winds. Southeast trade wind. Again, we'll try to name this one. The air that is moving from subtropical high at 30-degree north towards subpolar low at 60-degree north. So you can see the direction here. It is south and west, right? This is south and west. So you can call it southwest winds, or mostly we call it westerlies, northern westerlies. These are westerlies because it is coming from west, this western direction, westerlies. Then again, also this one will be westerlies because it will come from this northwest, means mostly western side. So it will be known as westerlies again. This will be known as westerlies. This wind will be known as polar. Say it is coming from northeast here. It is coming from the northeast. The direction is northeast. So you can call it easterlies, polar easterlies, polar easterlies. And this wind is also coming from southeast. So you call it again polar easterlies because it is coming from the eastern side, polar easterlies. So these are the different names of the wind that we find on the surface of the earth. On the surface of the earth, we can name the winds based on the direction from where it is coming. And now who is going to decide the direction? It is the Coriolis force. The Coriolis force will give a direction to the winds. And according to the direction of the winds, we have named the winds, the particular circulation of the winds. Okay, the names are northeast trade winds in this side, and this one southeast trade winds, and this northeast trade winds and southeast trade winds will converge, where it will converge at the equatorial low. Okay, so this is about the surface of the wind movement of wind at the surface of the earth. Now we're going to see the circulation over the earth, both at the lower part, both at the surface, and both at the upper part, lower and upper air circulation. Suppose for just for understanding, I'm drawing the earth like the polar areas are here 90-degree north and this is 90-degree south. Okay, just to describe the concept, I'm putting northern pole here and southern pole here. Okay, now what happens? I'll draw this little small. Okay, suppose this one is the equator 0-degree. This is the equator at 0-degree. This one is subtropical high 30-degree. Subtropical high again. This one is subtropical high 30-degree. Subpolar low 60-degree. Then again it is subpolar low at 60-degree. Now I'll try to see the circulation of the air on the surface of the earth, how the air circulates on the surface of the earth. So one thing before describing it, know that at the low pressure zone air converges, air moves from different directions. Okay, the low pressure zone, because there is a low pressure here, there is not enough air molecules are present here. So to fill this place, to fill this vacuum, to fill this space, air will come from outside, from the other side environment, from the remaining environment. So air will converge from all the sides in this low pressure zone. So one thing that you have to know is that in low pressure zone air converges, and at the high pressure zone air diverges, because there is a high pressure, enough molecules are there in this zone, air molecules are enough in this zone high pressure, so they will diverge, they'll move in different directions. High pressure then low pressure. In low pressure air converges, and at high pressure air diverges. Now we'll try to see on the surface of the earth and at the upper air how it happens, how it takes place. See, at the surface we have seen the trade winds, right? In the northern side it will be northeast trade winds, they're converging here. Northeast trade winds, they're converging here because it is a low pressure zone. At the equatorial low 0-degree it will be a low pressure zone, and the surface air will converge. This is northeast trade winds, this is southeast trade winds. Now when the air will converge, they will move towards the upper part. Once they converge, they will move towards the upper part. After hitting each other, they will move towards the upper part, because they cannot go towards the lower part because of the presence of this land mass. So they will move towards the upper part. Once they reach the higher tropopause zone, they will become, these air molecules will become cold here. Once they reach in the upper part tropopause zone, the air molecules will become cold. After convergence, they will reach here and they will become cold, and because of that a high pressure will, this zone will become a high pressure zone at the upper part, not at the lower part. Okay, this pressure zone will become a high pressure zone because the air is cold now. So they will diverge now in the different direction. The air will diverge in the different direction. Okay, since they are moving in this polar side, the airs are moving in the polar side, and as they keep on moving towards the polar side, there will be accumulation of air in this zone near this 30-degree. This air will get accumulated, there will be accumulation of these air molecules, and because of the accumulation of air molecules, and at the same time they're moving at a very higher elevation, at a very high altitude. Okay, and at this altitude, at this height, the temperature is always low, and because of this very low temperature and because of this accumulation of air at this 30-degree latitude, they will form, they will descend. They cannot hold themselves, the air molecules cannot hold themselves, and so they will descend because their density is increasing, because both of accumulation and decrease in the temperature. So they will descend here, this air will descend here. So it is happening here also, the molecules will descend in this 30-degree. Okay, they will descend here in the 30-degree, and a cell will form here, and again a part of this air will move in this direction. After coming down, another branch will move in this direction, because air is coming from the upper part, subsiding, air is subsiding from this upper part to the surface on the earth. That's why this portion is having a high pressure zone. This is a high pressure zone because pressure is being exerted by this movement of air molecules from the upper part. So here the pressure will be high pressure zone. Then again, after hitting the surface, a branch will move towards this one and it will become part of this southeast trade winds. And again, this branch will become part of this northeast trade winds. Okay. The next we'll see what happens from the polar areas. From the polar areas again, because the temperature is very low again, and at the same time, the pressure will be high. Because of very low temperature, the pressure will be high in the polar area, and because of that, air should move and air is moving from this polar area towards this subpolar low here at 60 degree. Air is moving here, and again air is coming from this side also, from this branch air is coming from this side also. So here they will converge again, they will converge this air, then again they will rise. Why they will rise vertically up in the upper part? Because in the downside they cannot move because of the presence of the earth. When they will rise here, a branch will move towards the polar side and they will subside at the pole, and another branch will move towards the subtropical high. Again, it will become part of this air mass. So we can see in the both the hemisphere, everywhere on the surface of the earth, we can find this kind of circulation. Here also you can find this kind of circulation. So everywhere surrounding the earth, you can find this kind of air circulation, a fixed pattern of air circulation, both at the lower part nearby the surface of the earth and both at the upper part, at the upper air circulation. You can find a fixed pattern of air like this. So the person Hadley, meteorologist, has described this cell first, and accordingly we have given name of the different cells. These are actually like compartments, and we call it cell, and this cell has been named. Okay, first it is the first cell nearby the equator is called Hadley cell. Hadley cell. Okay, this compartment is called Hadley cell, and this compartment, this one, in between 30 degree and 60 degree is called Ferrel cell. This one also called Ferrel cell. Then again, this cell forming at the polar area in between 60 degree north, 60 degree north and 90 degree north, and 60 degree south and 90 degree south. We'll call it polar cell. So this is how different cells are also formed. This is how different cells are also formed. Now we have seen this is called general circulation of the air. This is the general circulation of the air earth, over the earth, both at the surface and both at the upper air. We can find this kind of fixed pattern of air circulation. Now who will decide what are the factors will decide this movement of the wind? Factors like Coriolis force and presence of different pressure belt. Now how pressure belt will form? Because of difference in the temperature. Higher is the temperature, lower will be the pressure. Low will be the pressure. More is low is the temperature, means cold. High will be the pressure, and based on that we can see formation of different pressure zones at different parts of the earth, and because of that this air moves, they keep on moving. Sometimes the pressure belt, the intensity of the pressure keeps on increasing or decreasing. Sometimes the high pressure zone becomes, the intensity decreases. The high pressure, it doesn't remain the same amount of, the magnitude of the high pressure decreases, and sometimes the magnitude of the low pressure also decreases, and because of that the low pressure zone will become sometimes little bit high pressure, then again this high pressure zone will become little bit low pressure. And because of this oscillation of this pressure, we can find the intensity of the air is not, the speed of the air is not as high every time. Sometimes the air movement of the air will be slow, sometimes it will be fast, based on the intensity, magnitude of the pressure on the different areas. So this is called general circulation of the air. Now we are going to see different types of winds on the surface of the earth. First one is seasonal wind. Seasonal wind. Now what is seasonal wind? Seasonal wind is a wind, a kind of wind. Okay, we can find this wind in a particular season of the year. We can find this kind of wind in a particular season of the year. You can give the example of monsoon. The monsoon wind that comes in India, in the Indian subcontinent, that monsoon come in a particular season of the year, in the summer time. Okay, after June, in the June we can find monsoon. So only in June or in the summertime we can find monsoon. So this is a seasonal wind. Monsoon is actually a wind, and this wind brings the moisture from the Indian Ocean, and that causes rainfall in the Indian subcontinent. We'll read about Indian monsoon in detailed manner in our later videos. So this is an example of seasonal wind. Then there are some wind called local wind. Local wind, we can see local wind in some portions of the earth. Within the country only, you can find different kinds of local wind. Now, how does local winds are formed? Because of local conditions. Okay, locally there can be changes in the pressure. In a particular area, there can be changes in the pressure. In some part, it may become high pressure, and some part it may become low pressure. Locally, at a local region, not at a very high area. It is not going to cover a very big area. So, for the best example will be Lu. We can find Lu. a very warm, hot, dry wind in the northern plain during summertime. In this, from starting from this Rajasthan area to crossing UP, Delhi, then Delhi, UP up to Bihar area, you can find this low. Okay, this is a local wind. Then next we are going to see about breeze. Breeze. Breeze means shooting air. Okay, two kind of breezes there. One is sea breeze and one is land breeze. Sea breeze and land breeze. First, we'll discuss what is sea breeze. Suppose this is the area nearby the coast. This is the coastal area, and this is the land mass. This is the land, and this is the sea water. This is the sea, and this is the land. Okay, this is a land mass. Now, one thing you have to know before described in this land breeze and sea breeze is that land becomes warm up very fast. It becomes hot. Land becomes hot very fast when the sun comes in the morning. When the sun come out in the morning, the land become hot very fastly because land is opaque. It is a hard opaque object. It is opaque. So the surface will absorb the heat, the energy of the heat. It will become hot very early. But the the water body, the sea part, the heat, because sea is translucent, it is not opaque. Sea's water body is translucent. It is not opaque. That's why it have to absorb heat for a long time to become warm, because the heat, the sunlight will enter inside the water body also up to a certain distance. Up to a certain distance, beneath this surface water, the water will go inside the water body, and that is why it will take some time to warm up all the molecules of water. That is why water becomes warm up after a very long time. In the same manner, during night, at the evening, when there is not sunlight, land also become very cold. Not very cold actually. Land also emit the heat very fastly. Okay, they also heat absorb the heat very fastly, and again they release the heat, also emit the heat fastly. So the land will become cold at the night. But the water body, since most of the molecules have absorbed the energy of the heat, so again these water molecules will take time to cool down. So during evening time, you can find land is cold, but water body is still warm, because it will take a long time to release all the heat. Now from here, what we have understood is that land becomes hot very early. It will become warm. It will become warm very early during daytime compared to water body, and again at night time the land will become cold early compared to the water body. Water will take a time. It will take some time to release the all the heat. So accordingly we'll see what is land breeze and sea breeze. This is the land, this is the sea again. See, during daytime, what is happening now? The land has become warm because of the coming of the sunlight, and because of this expansion, the density will decrease. The density will decrease, and because of that, the air molecules will expand and they will rise, and a space will be created here where there is not enough air molecules. Okay, now here we'll see in a sea level what is happening here, because still the sea is cold. It is warm now, but here the sea is still cold. Why it is cold? Because it has not yet absorbed all the required heat that is needed to get warm. Okay, so it is taking some time. So till now, during the daytime, during morning time, it will be cold. So the pressure here will be high pressure. Since it is cold now, it is high pressure, and here it will be low pressure because it is warm now. So air will move from this high pressure water molecules, water surface, towards the low pressure land mass. So during daytime, when the landmass is warm, hot, we can find breeze, cool wind coming from water body. Okay, nearby big rivers, or you can find nearby lakes also. You can find cold wind is coming. Cool wind is coming from this water body towards the landmass. Why it is coming? Because of formation of different pressure. Low pressure at the over the landmass and high pressure over this water body. This is called sea breeze. Why sea breeze? Because this breeze is coming from the sea. As I have already discussed that we name the winds from the direction from where it is coming, and here we can see that the wind is coming from the direction of the sea, so we call it sea breeze. And what is land breeze? The opposite of sea breeze is land breeze. Now when it happens? During the evening time. Suppose there is no sunlight now, evening time. This is the land again, then this is the sea. The land. So again, see, during the night time, what will happen during evening? The land will again emit all the heat very fastly. Okay, so because of releasing the heat, it will become a cool surface now. The landmass will become a cool surface compared to this sea, because the sea will still take time to release all the heat it has absorbed. So it is a warm surface now during evening time when there is no sunlight. It is warm now. So because of warmness, it will become the pressure will here will be low pressure. It will be low pressure here, and here it will be high pressure because it is cold. So from where air should move? Air should move from land to water. So from high pressure to low pressure. So this kind of wind, when they move from high pressure to low pressure, this kind of winds are known as land breeze. Why land breeze? Because they are coming from land. That's why it is called land breeze. So this is the sea breeze and land breeze. Now there are some other kind of winds. We'll name them. First one is valley breeze. Valley breeze. Then again, from name only you can say from where this wind is coming. Of course, the wind is coming from valley. Suppose this is a hilly area. This is a hilly area, and the slope has become warm during the daytime. Suppose the slope has become warm in this part, and because of this warm, getting warm of this part of the slope, it has become hot, and the pressure here will be low because it is warm now. It will be low pressure. This valley is not enough warm compared to this portion slope, so it will be a high pressure zone here. Then air should move from high pressure valley towards the low pressure slope, from the valley region towards the hilly slope area. So this kind of wind that is moving from this valley towards the slope is known as valley breeze, and the opposite will be known as mountain wind. Mountain wind. Now what happens in mountain wind? Again, from the name only you can say from where the wind is coming. It is coming from the mountain. Suppose this is a mountain area, and during night time, when the air here will be cold, it will, because of high density, gravity will pull this air towards the plain area. So this kind of air, because it is cold here during night time, so it will be high pressure zone. It will be low pressure. Again, because of pressure gradient and also because of the pulling of the gravity, it will move towards the low pressure area in the plain area, and this kind of wind is called mountain wind. And another wind is called katabatic wind. Now katabatic wind is same as mountain wind, but there is only one difference. Katabatic wind. Now what happens in katabatic wind? Again, wind will move from the upper high slope towards the lower part, plain area. Okay, but this wind will come from surface of high plateau or high mountainous area where there is ice, where is covered with ice cap. Okay, if the high mountain area or under high slope or any high plateau area, if it is covered with ice cap, then the air will move from this ice cap because of high pressure zone, low pressure. So air will move from this ice cap towards the valley area. So this kind of wind is known as katabatic wind. It is same as mountain wind, only difference is that it is covered with ice. So the temperature will be very low in this katabatic wind. And one is orographic wind. Now what happens in orographic wind? Suppose this is a mountain here. This is a mountain or a hilly area. Now what happens if air comes from a particular direction? When the air comes from a particular direction, suppose this air is coming over a surface, water surface. The air is coming over a water surface. So while moving towards the hilly area, it will pick up the moisture from this water. Suppose the monsoon wind, suppose this is the example of monsoon wind, and it is picking up the water molecules from the Indian Ocean while moving because of the friction. It and evaporation, high amount of evaporation in this tropical Indian Ocean. This water molecules will be picked by this air, the movement of this air in the horizontal manner. This air will bring this air, and it will hit the one part of the slope, wind facing slope. The wind facing slope will get hit by this air mass, and because of that, they will rise. This air will rise vertically. They will rise along the slope, and once they reach a location, a altitude, at elevation or height where the temperature is low here, temperature here is low. So these air molecules will condense here. Means they will form cloud. The air molecules that is present with this sorry, the water vapor, the water molecules that is present with this air Once they reach this height, they will become condensed and they will form cloud, and because of that there will be rainfall in this side. In this hilly side we can find rainfall. But once the air has shed all their moisture, they will again move towards the opposite side, and this wind is not having any more moisture. It is a dry wind. This kind of wind is called, it is a dry wind. This is a humid wind, moisture carrying wind. This is a dry wind because it has left all its moisture in this side, in the windward side. And again, when it will move, this air will move in the opposite side of the slope. It will be dry and warm wind. Okay. So in this side, we cannot find rainfall. There will be no rainfall in this side, but there will be enough rainfall in this side. Okay. So this side of the slope is known as windward side. This slope is known as windward side. Windward slope. And this part of the slope is known as leeward slope. Leeward slope. So you will find very less or there is no rainfall in the leeward slope. In this side there will be no rainfall because there is no moisture. There is no any moisture in this side. So in the leeward slope we cannot find rainfall. But in the windward side we can find enough rainfall because of this orographic. This kind of rainfall is known as orographic rainfall. Why it is taking place? Because of this presence of mountain or hilly area. Oro means mountain. Okay, because of this presence of this mountain or hilly area, we can find this kind of rainfall, and this is called orographic rainfall. So this dry wind is actually helpful in some of the countries. It may not be helpful in countries like India, where this wind leeward slope, leeward side we find in the country in the upper and the opposite part of Western Ghat. Suppose this is the Western Ghat. Western Ghat. In the Western Ghat, in this side we can find enough rainfall, and in the opposite side we cannot find enough rainfall, and there will be drought in this side. Because of the drought, we can find lots of problem related to agriculture. In the Vidarbha region of Maharashtra and again Telangana, all these regions they fall under this leeward slope, leeward side, and because of that, there is less amount of rainfall here. And because of that, since our agriculture is mostly rain-fed, the farmers it becomes difficult for the farmers because they do not get enough rainfall because of the presence of this hill in this manner. So why where it will be helpful? In which countries this dry wind will be helpful? There are two kinds of winds at the world level. One is Fawn wind in the Alps mountain, and one is Chinook wind in the Rocky Mountains. Chinook wind in the Rocky Mountains of USA and Canada, and this one Fawn wind in this Alps mountain. So nearby Germany, this Fawn wind we can find. So what they do, what does Fawn wind and Chinook wind do? Mostly this Chinook wind, what they do, they help these dry winds in Rocky Mountains of US and Canada. They helps in the melting of the snow. They helps in the melting of the snow in the leeward side. In the leeward slope, they help in the melting of the snow, and because of that, the this wind, this warm and dry wind, they melt the snow in this side, and so that the grasses can come out because of the melting of the snow. Because since it is a dry wind and warm, so it will obviously it is going to melt the snow in the other side. Since after the melting of the snow, the grasses and small plants will come out, and the cattle can go there and graze. Cattle can graze there. So it is very helpful for the nomadic people. For the nomadic people, it will be helpful. So since they can bring their cattle to for the grazing purpose here, since the grasses will come out because of the melting of the snow. So here we have seen the different types of air, and the how this air molecules, how this air, uh, because of the difference in the pressure of the air, movement of wind take place from high pressure to low pressure. And because of the movement of a wind from high pressure to low pressure, we can find the circulation, the general circulation of the air over the surface of the earth, and both at the surface and both at the upper air. One more topic I'm going to discuss: air mass. Now what is air mass? Air mass is a mass of air. It is a mass of air. Okay. In different part of the world, in different part of the earth, you can find different air mass based on where it is present. If the air mass is present in a hot region, suppose it is a very hot region, and here is humidity is very high, hot and humid, and this region is very cold and dry region. So the air that is present in this portion of water surface for a long time, it will absorb the characteristics of this particular place. It will actually acquire the properties, the characteristics of this place. Means the air here, the mass of air here will become hot and humid. And again here in the over the cold and dry region, the air that is present for a long time over this cold and dry region will become the air also will become cold and dry. So this kind of masses, that is static masses of air that is present over the surface of the earth for a long time, it will acquire the property of that particular landmass or the water body. So this kind of mass of air is known as air mass. And on different part of the landmass or water body, you can find different air masses. So accordingly, we can divide the air mass into different parts like maritime, tropical. Maritime tropical means in the tropical area, water body. Maritime means water body in the tropical areas nearby the equator or in the subtropical region where the water is very hot and humid. So in this maritime tropical water air mass, this is the kind of air mass. In the maritime tropical air mass, we can find that the air will be hot and humid because maritime means water, tropical area. In the tropical area, the water will have more highly evaporated in a highly evaporated state. So because of that, humidity will be very high. At the same time, because of the presence of enough sunlight, the temperature will be hot. So this air mass will be hot and humid. Then again, continental tropical city, continental tropical. So continent means this air mass will be present over land mass. Land mass mostly over the desert areas. In desert areas, what we can find, the temperature is very high. In desert, the temperature is very high, hot, and the humidity will be very low. It means dry, hot and dry. So the air mass that will be present over the desert area will acquire the characteristics of this desert, that is hot and dry. So this kind of air mass will be known as continental tropical, means hot and dry. Then continental maritime polar, MP maritime polar means in the cold countries, in the cold areas, in the cold areas where the water body is present, the air will have low humidity. Humidity will be low. Temperature also will be low. It will be cold and it will be dry compared to the other landmass. So in the maritime polar area, maritime means water. So the air is present in this cold countries over this water body. So this kind of air will be known as maritime polar. Then again, continental polar. CP, continental polar means in the polar area, but the air mass is present over this continental land mass. So again, it will acquire the both the temperature and humidity of this land mass, continental polar. Then continental Arctic. Arctic means pole, exactly at the pole. Now, what will happen exactly at the pole? The temperature will be it will be very low at the Arctic or polar region. The temperature will be very low. It will be the temperature will be very low, and the humidity also very low. Means it will be totally cold and dry in the polar area. Okay, exactly over the pole, the air mass that come from the pole is called continental Arctic. Means it will be very cold and it will be very dry, both at the northern hemisphere, North Pole and the South Pole. So these are different air masses. Now we have divided the air masses based on where it is present, where the air mass is present, where it is present over a landmass or a water body for a long time. If it is present over any surface, it will acquire the property of that particular area and they will become a air mass. In the next chapter, in the next video, we are going to see how this air masses, the different air masses that origin in from different places helps in the or causes the disturbance of the weather, and we can find different types of weather phenomenon like tropical cyclone, then again tornadoes. All these activities we'll see in the next video. Thank you so much.
Subscribe to Careerflite and press the bell icon to never miss our videos.